Alright, so basically what we have is our first free response that was on a previous AP exam. So the rate of consumption of cola in the United States is given by ST, which I will write down. S of T is, so it should be S of T should equal C times e to the kt. So that is S of T. So where S is measured in billions of gallons per year and T is measured in years from the beginning of 1980. So basically we have a multi-part question. So the consumption rate doubles every 5 years, and the consumption rate at the beginning of 1980 is 6 billion gallons per year. And we're basically trying to find C and K. Find the average rate of change over a 10-year time period beginning January 1st, 1983, and indicate the units measured. Use the trapezoidal rule with 4 equal sub-intervals to estimate the area from t equals 5 to 7. And then using the correct units, explain your previous answer. So it should be from t equals 5 to t equals 7. To be more concrete, in terms of coal consumption. So I'm gonna give you guys about like 10 seconds to write everything down, or like try to solve it on your own, and like pause the video and see if you can try to do this on your own. Alright, so for part A, we're basically trying to find C and K. So we know that it doubles every 5 years, and initially at 6 billion. So what I'm going to do is I'm going to make a table. So this is going to be T, and then this is going to be S of T. So let's just have 0, 5, and 10 for now. So we know when you plug in 0, it's going to be 6. So using that, we could already solve for C. So basically 6 equals C E K times 0. So this is the same thing as 6 equals C e to the 0. And e to the 0 is just 1. So you get a C value of just 6. Now, it doubles every 5 years. So when t equals 5, or 1985, it would be 12. And then at t equals 10, it would just be 24. So now we're going to try to find K. So let's try to plug in points. So S of T is 12 when T equals 5. So something like this should work. And then we just have to solve for K. So we divide by 2 on both sides. Divide by 6 on both sides. We get 2 equals e to the 5k. And then we can take the ln on both sides. So you get ln 2 equals 5k ln e. That just becomes 1. So you basically get a final answer of 1/5 ln 2 equals k. So our function is S of T equals 6e to the 1/5 ln 2t. And then we see that the ln2 and the e will cancel out, so it'll just be 6 equal. So s of t is just 6 and times 2 to the 1/5 t, if you want to rewrite it like that. Alright, so next is part B. So part B is to find the average rate of change of the 10-year period starting from 1983. So beginning of 1983. So let's like make another table. So at t equals 0, t equals 0, not 9. So at t equals 0, it is 1980, and then t equals 1 is 1981, and then t equals 2 is 1982, t equals 3 is 1983, and so on and so forth. You get the pattern. So starting from t3, t equals 3, and then we're going to do it for 10 years. We're going to have a 10-year period starting at this. So don't do 0 to 10. We're starting right here. So we're going to go from 1983 to 1993. So that'll just, so if we like keep doing this, you get t equals 13, and that's 1993. So basically, when you're trying to find the average rate of change, and you're given the original function, when you're given a rate already, you basically have to do this. So you have to find the average value. So 1 over 1 over b minus a, and then times the integral of a to b of f of x dx. So let's apply that. So you get 1 over 13 minus 3, and then the integral from 13 to 3, and then you get s of t dt. So that just equal to 1/10, and then integral 3/13 of s of t. And this is a calculator. You're allowed to have a calculator, so you could just plug the function right in. So when you plug in everything, you should get 19.680 billion gallons per year. Alright? Now, part C, we're basically trying to use the trapezoidal rule with 4 equal subintervals. So when it says n equals subintervals, that means n number n rectangles. So say if n is 4, you would have 4 rectangles. So say if you have a of 1 and a of n, there should be n minus 1 points between. So in this case, our a of 1 is 5, and our a of n is 7, and then there should be 3 intervals in between 5 and 7. So then we can make 4 rectangles. So if you recall from sequences in series, this formula, this is explicit formula for arithmetic sequences, for arithmetics. So it's a of n equals a of 1 plus n minus 1 times d. And we're just trying to find D here. So this is there's 5 terms here. So a of 5 and then equals a of 1 plus 5 minus 1 times D. A of 1 is 5, and then this plus 4D, and then a of 5 is just 7, so we just have to solve for D. So this is 2 equals 4D, and then you get D equals 1 half. So we go back here, we just keep adding 1 half until we get to 7. So 5.5, and then this would be 6, and then this would be 6.5. So now let's actually plug it in to a graph. So we have our function s of t equals 6, and then 2, so 1/5 t. So let's this is not the exact curve. This is not the exact curve. But I just want to give you a visualization of what you want to do. So basically, it should look something like should it should look something like this, right? So it should look something like this, I believe. Let me just double check. Let's just say for now, like it looks something like this. You'll have a better representation of the graph if you graph it on a calculator, but it probably looks more like this. So let's have 5 be here and then 7 be here. So this is a zoomed in of the graph. So and then we have our sub intervals. So we have 5.5, and then we have 6, and then we have 6.5. So let's plug in points. So s of 5 equals 6 times 2, and then 5 over 5 times t. I mean 5 over 5, my bad. So that's just 12. So we have 5, 12 here. And then we're going to plug in 11 over 2. So that's s of 11 over 2, and then equals 6 times 2. And then this would just be 1.1. So whatever that is, you can calculate that. So this would be 5.5, and then 6 times 2, 1.1. And then we're going to find s of 6, and that's 6 times 2, and then times 6 over 5. So on and so forth. So next we're going to draw trapezoids to each point. So let's try to connect the dots, but sketch trapezoids in between those intervals. So now we just have to find the area of these trapezoids. So an area of a trapezoid is y1 plus y2, and then over 2 times delta x. So our delta x is always 1/2. So basically we're gonna have uh, so basically we're gonna have s of 5 or plus uh, s of 5.5 over 2 times 1/2, and then we're gonna have plus 1/2 s of 5. S of 5.5, and then plus s of 6 over 2, and then this keeps going on and on. Let me just make this easier and distribute uh, the 1/2s. So this is the same thing as 1/4, and then you get s5 plus s 5.5, and then you get plus s 5.5, and then plus s6, and then plus s6, and then plus s6.5, and then plus s6.5, and then plus s7. These should be s's, not sixes. So basically, when you plug everything into your calculator, you should get around 27.668, and this is for part C. So now for part D, we basically had to interpret the meaning of this integral. So 5 to 7 s of t dt. We're basically trying to interpret its meaning. So let me just start off with just units to make a little more sense. So s of t is measured in gallons per year. We could say like bill gallons per year. And then dt is just years. So basically when you take the integral, these cancel out. So you just get units of bill gallons. But we remember from fundamental theorem of calculus, FTOC, that if you have the integral of a to b of f of x, that's the same dx, and that's the same thing as f of b minus f of a, or the total change in f from a to b. So we can rewrite this as at 5, 7, and then s of t dt. So we get, let's just call our new function c for now. It doesn't really matter what you call it. So we get c of 7, and then minus c of 5, right? Or, and this is the delta c from t equals 5 to t equals 7. Or in this case, it would be January 1st, 1985 to January 1st, 1987. So, let me put some more space here. So we have our delta C from t equals 5 to t equals 7. So that's 1, 185, and then 1, 187. So what is our delta C? That is our total change. And remember what I was saying about the units? This is measured in billions of gallons. So basically, replacing everything. Total change of blank from 1,185 to 1,187. Now, what is supposed to be that blank? Remember, what does S of t measure? What is S of t measures the rate of cola consumption. And basically, since we're trying to integrate, it basically changes the original function to measure the amount of cola consumption. Because if you do dy over dx and then times dx, the integral, and then that'll just be y. So you have a rate multiplied by time. That's just the original cola consumption, if that makes sense. So it's the total change of cola consumption from 1,185 to 1,187 in billions of gallons. Because remember, if you have, because if you're integrating a rate, it's just the original thing. Just like how s s of t is basically like c prime of t, the rate of coal consumption. The original function just measures the coal consumption. Just like if you find the rate of change of, like, say oranges falling, like the rate of change of the number of oranges falling. If you just integrate that, it's just, the original function is just measures the number of oranges falling. If that makes sense.